Well there, hello everyone, this is KP the MFG. I'm all smiles because we're doing another YouTube video on AP Calculus. I love it. I love what I'm doing. I really am excited about anything that we do up here. Really I am. Well, let's look at the problem here. Problem's really not written down per se. I tried to write it down yesterday and it took up too much space, so I'm just going to try to abbreviate just a little bit and we'll get the idea of what needs to be done here. There's a reason why this is x equals instead of y. The g at x is referred to as y here, and so what they really did is they solved this one for x. Okay, and this turned out to be the inverse of g at x. And they called that, instead of g at x, they called this h at y. Anytime you want to say g at x, everything's in terms of x. Anytime you want to say g at y, everything's in terms of y. So that's why this x is equal to h at y. Alright, so this is h at y right here. H at y. There we go. Okay, h at y. Okay, well, let's take a look at this. What are we doing here? What we're doing is this region, T, alright, is a triangular. Actually, this is a curve. So it can't be really totally triangular. It's supposed to be a curve. Although sometimes when I try to draw a straight line, I draw a curve. And when I try to draw a curve, I draw a straight line. Figure that out. Anyway, a curve. Alright. Kind of triangular. This region right here. It's bounded by the curve, the line y equals 3.5, and then the y-axis. We might say x equals 0 sometimes. The y-axis is x equals 0. The x-axis is y equals 0. Okay. So that's the region T. So you have to kind of get what the region is that that's under consideration. It's fairly easy to see that this is the only region we're concerned about. Okay, and so let's go ahead and talk about it. What are we trying to do? We're trying to revolve the area or the region label it as T, about the line or about the y-axis or about the y-axis, or we might say that looks like 5 axis, and in this case we're saying x equals 0. So you got to be familiar that sometimes if they say about x equals 0, that is the y-axis. And sometimes students miss that and they try to revolve that about the x-axis. X equals 0 is the y-axis. Alright, now let's do that, and we'll try to find some of my colors is trying to fade. Got a new box and I did open them, and you know, I kind of mixed them up, so I got to figure out which one is are the newer ones. Okay. Anyway. Alright, so what does that mean when we're revolving something? When we revolve something about an axis, we're making a circle. Alright? So what we're doing is we want the area of the circle, and it's a volume times this thickness. Okay, the thickness is this isopinterval. Right there. This little isopinterval right here. That's delta x right here, which we say dx. Alright, so actually what we're doing is we're going to go from A to B, and this is a radius right here. So if it's going to go in a circular region, this is a radius here. And by the way, incidentally, this distance from here to here, we don't know what the distance is. Well, we really do. But we're going to say it's x. It's some x, isn't it? Well, what is x? X is h at y. H at y is this. Okay? So we're going from A to B. Alright? And when we're taking the volume, we've got to get the area of the circle. So the area of a circle is, we're just going to put the pi on the outside. Pi r squared, which in this case is x squared, right? Pi x squared. And then the thickness of this is dx. So that's the volume. Pi r squared, there's your area right there. These two parts are your area, and then this part right here is your thickness. Okay, pi r square h. Okay, well, anyway, there it is, and that's what delta x stands for right there. So that's what the volume is. So that's what it's going to be, a volume of revolution. Okay, now from A to B, this isopinterval can go as low as 1 and as high as 3.5. We can move that thing around. I don't know where I got it. I got a little bit above 2. It doesn't matter where it is, but it can be as low as 1 and as high as, we want to cover that entire region. So it's going to be from 1 to 3.5. Now, we can't just say x squared dx. X squared is really, that's your radius, r squared dx. X squared, this is actually the radius, which is r is equal to x. Okay. But x is equal to h at y. So we could say h at y. H at y, not h at x. H at y, and we're squaring that and putting that dx on there. And really and truly, that's it, because it says do not evaluate. It says let t be the region bounded by the graph of x equals h at y, the y-axis, and the horizontal line y equals 3.5. Already showed that. And you got to get the boundary set. Right, but do not evaluate an integral expression that gives the volume of the solid generated when region T is revolved about the y-axis. So if you already know that h at y is equal to this, I'll just write a little plainer here. Hopefully I will write a little plainer. So h at y is equal to x, which is equal to all this. If you wanted to, you could have, instead of doing that, you could have said, alright, well, so an expression, that means I can write anything that's legal, okay? It's got to be a legal expression. We could have just wrote what x is. We could say, well, 12y minus 12. You don't have to factor out the 12. Just let it go. 14 minus y. And then you could do that square and put dy right there. There it is. You got it. Either way, now if you want to save yourself some time, you already know that that's h at y. So don't even, look, don't even you're going to get credit for it, I promise you. Don't sweat that. Don't even try to write that out. If you're pressed for time, H at Y has already been given. You labeled what it is. So we're going to say it, what it is. H at Y. H at Y. I am so clumsy with writing, I tell you. Well, here we go. At least I know green shows up real good. H at Y squared. If you want to put brackets around like that, you can. And now make sure you square it. Pi r squared, and then the thickness right here, dy. Alright, so I've got dy, so we'll make it in green. There it is. That's it. Anyway, either way, if you put this whole thing in there, you can't just put x. You gotta say what x is. It's h at y. H at y is this. Either way would have been just fine. Pi r squared. You're going in a circular motion here. It's a circular motion. I can't go out far enough here. And it goes all the way around. Okay. All the way around here. What it's doing is it's going around. So this part is going back in behind here. Okay. Like that. That's what it's doing. Alright. It's rotating. So it's revolving about this line, x equals 0, or the y-axis. And there it is. That's your radius, r squared. This is a circle. It's not a, I draw it like an ellipse, but it's still a circle. Okay? It's a circular rotation. All of them are. It's always going to be pi r squared. Now there is a, I got to look that up again because I haven't done it in a while, but there's also a shell method which still allows you to bring this, but that's a different story. We're just going to let it be like this. This is good. Right here, you do want this, if it's revolved around this axis, you want that to be running perpendicular to that. See? They want to see. Now sometimes what they'll do is they'll start off with this and say they want it to revolve about this. You can't put this x. Okay, you got to solve for x. This is x right here. This length is x. This radius is x. So if you want this radius to be x instead of y, this is y here. You can't have y and x. You got to have x right here, and then solve that, and then call it h at y. But anyway, that's just how it is. Sometimes you got to solve it, but they've solved it for you. Okay, in this particular case. All right, well that's all I have to say about that. You know, if you like to, hit that subscribe button. If you don't want to, all right. Okay. I won't lose too much sleep over that. Hit that subscribe button. If you would like to hit the like button, please do so. If you'd like to hit the comment button and make a comment, please do so. I invite all of that. And so, anyway, I enjoy doing this, but it's not for me. It is for you. Okay, it's for your benefit. KP the Math G signing off. Ladies and gentlemen, have a great, great day.